Hi guys, welcome back from the ad break. So now we've come to the last segment of our show where we are still looking at some quadrilaterals riders, right? To try and solve some questions based on now either maybe a rectangle or a rhombus. But let's see what quadrilateral you have next. So I want you to please stay tuned with me as we are doing these last questions that we have. So remember guys, this map of mine is very important. Read through the facts, mark on the sketch, go to the implicit. So because it's a parallelogram, what else do you know that is not told? Read through what they want you to do, a plan of action, evaluate it, and always restart. So please just remember to always do these things. And it is really in this order, guys. I promise you, it starts here. There is nowhere where it starts other than you reading the statement. Now, if we have a rhombus, right? So it means our quadrilateral now is a rhombus, which is a very interesting one. What do we know about it? All the properties of a parallelogram are very true when it comes to a rhombus. Now, what makes it different from a parallelogram is that the sides are equal, all of them. The diagonals bisect at 90 degrees, and then the diagonals bisect the angles as well. So these three things are what makes it a very different parallelogram. So if I wanted you to then prove that something is a rhombus, it means you would try and uphold the properties of a parallelogram, but that will not be sufficient, because then you would only have proven it to be a parallelogram. To make it a rhombus, then you must add one of these three properties in order for it to make sense. Now, here they say RSTU is a rhombus with RU produced to V. I'm stopping there. I don't even want to continue. So what do I know? I know that this angle here will be equal to that angle there, right? That's because it's a diagonal, which will be equal to that angle, which will be equal to that angle, right? And then because of that, it would mean that this angle here will be equals to T2 plus R2, right? Because it's an exterior angle of a triangle. And then you can always talk about the other angles based on that. But for now, let's just see how we can use that after what I've just mentioned now. So they want us to prove that U1 is equals to 2T1. So that's how the diagram will look because of my nice properties that I know of a rhombus, right? By the way, we call it a rhombi and triangles, right? Because if we're trying to look at it from a point of how many angles are there, which is a plural, right? Now, if we want to use the deductive reasoning for this, I want to prove that U1 is equals to 2T1, right? Which is the same as T1 is this angle there, right? Which is the same as 2R, what is this? R2, which is also the same as that one there, 2T2. So I must make sure that I understand what I'm trying to do here. So I'm going to first say U2 is equals to T2 plus R2. So I will try apply this and see whether it will work, right? Exterior angle of a triangle. And then from there, let me actually write my reasons properly, guys, so that you know that you are required to write them properly. Exterior angle of a triangle. And then from there, what do I know? I know that T2 is the same as, rather I will say R2 is the same as T2, which is the same as T1, not R, T1, right? This is the same as T1, and this will be because there's alternate angles. That is because ST is parallel to RU, right? Then from there, what do I know? I know that it means U2 will actually be the same as, if I want to add these angles, it will be T1 there plus T1 there, right? Which is the same as U2 is equals to 2T1, right? Then from now, I want to then relate this to U1, right? Because I'm only talking about U2, right? So there's what we call, if I want to relate it to U1 here, there's what we call an exterior angle of a cyclic quad, which will be equals to that angle that I have there, right? So I know that U2 is equals to also S, and this is because exterior angle of a cyclic quad, right? Or an exterior angle of a quadrilateral, and then as a result, it means U1 will be equals to S, which will be equals to 2T1, right? U1 and S are equal because these are opposite angles of a rhombus. And that's how you can then prove what they want us to prove. Now, another question that we have here. So this one, guys, I promise you, you need to make sure that you are paying attention and your algebra skills are on point. So here it says, in the quadrilateral ABCD, diagonals AC and BD bisect at O, right? So AC and BD, making this to be equals to that, making this to be equals to that. Immediately I know that it makes this a parallelogram, right? And then what do I now want to do? I want to prove that this is a rhombus. So before that, let's just add a few of the things that we know. So we know that this will be the same as 2xy, and that will be 2xy, because it is bisected, right? We were told that this is bisected. And then this one and that one, I want to know what it is. So this will be not 2, just x. This one will be x squared minus y squared, and then this will also be x squared minus y squared, right? And then I can then try use all of these nice things that I have here. So remember, for me to prove that this is a rhombus, already I know it is a parallelogram because the diagonals bisect. I must just prove that this is 90 degrees. So this is my required to prove, which is RTP, right? I must prove that this is 90 degrees, right? Which is BOC is equals to 90 degrees. If I can prove this, guys, I would really would have done what they wanted me to do, which is just to prove that this is a rhombus. Now let's quickly, again, remember I said you must add either all the sides are equal, diagonals bisect at 90, or the diagonals bisect the angles. But with the angles, it will be a bit difficult because then we will need to measure. And remember, geometry, we don't measure, we just apply the theorems and the properties. Now I'm going to use this triangle here, right? In this triangle, if I find that this squared is equals to this squared plus that squared, then I would have proven that this is a rhombus. So let's quickly try and do that. So I will first say the left-hand side, right? Or not even the left-hand side. Okay, let me write it as the left-hand side, right? So I will say the left-hand side will be, let's take it as the hypotenuse side, x squared plus y squared, right? Now I must square this. So to square this, it will be x to the 4 plus 2x squared y squared, and then plus y to the 4, right? And that's what I will have there. So it will be those two times together times 2, yes. So this is what I will have on the left-hand side if I call it my left-hand side. And by the way, my left-hand side is BC squared. Now I want to know what is BO squared plus also OC squared, which will be equals to, let's look at BO. BO, we know that this is x minus y squared, and then it will be plus, I square this, 2xy squared. Okay, and therefore this will then be equals to, if I simplify this, it will be x to the 4 minus 2x squared y squared plus y to the 4, and then plus 4x squared y squared. And then as a result, this will be equals to x to the 4 plus 2x squared y squared. Why? Because these are like terms. This one here and that one there are like terms. And then lastly, it will be plus y to the 4. Hey, guys, look at this. How beautiful is this? This is the same as that I have there. So as a result, you will then claim that, therefore, BC squared is equals to OB squared plus OC squared, which means that BOC is 90 degrees, then ABCD is a rhombus, right? And the reason for that will be the diagonals bisect at 90. Diagonals bisect at 90. Bisect at 90 degrees. And that's what makes it a rhombus in that particular regard. So I hope that clarifies a lot of things, guys. Remember, you always need to make sure that you understand what is given, what is required of you, and what is it that your plan is going to be, and what is it that is hidden from what is given. Because the times what they give you is not what you're going to apply. You're going to apply the hidden information about what is given. Guys, we've come to the end of our lesson. I hope you've enjoyed as much as I have as well. But remember, every good thing needs to come to an end. Until next time, please look after yourselves, and remember, mathematics is food for the soul.